Okay, this video will introduce related rates types problems. Before we consider an example, something you might want to be aware of. If you look at your textbook and with your related rates types problems that you're asked to solve, if you read through all of them, you'll see that they're all the same general type, they're all the same general format. Typically, you're given some variables, and you're given the rate of increase or decrease of those variables, and then you're given another variable, and you're asked to solve the rate of increase or decrease of that particular variable. And the trick involved, if you will, is the same. You want to think of an equation that relates all the variables together in a single equation. And then you take the derivative of that equation, and that sets you up then to find the rate of change of that particular variable that you're asked to solve for. So with those comments in mind, here we have a simple problem here that we're going to illustrate the technique with. And the problem is this. We have a giant balloon, and it's being inflated at the rate of 100 cubic feet each minute. And we're asked to find what is the rate of change of the radius at the moment when the radius is equal to 3 feet. So there's two main variables in this problem, the volume and the radius. And since this is a balloon, we can assume that we're dealing with a sphere. We know the rate of change of the volume of the sphere, that's this. Now we're asked to solve for the rate of change of the radius at the moment when the radius is equal to 3 feet in length. So if V is the volume, we are told what dV dt is. That's 100. And I'm not going to write down the units, I'm too lazy. And we have to solve for dr dt when r equals 3. Notice r is measured in feet, and the volume is in cubic feet, so we're using the same unit of measurement here. Okay, so we're given this information, and now we want to find out what this is when r has that particular value. So right now then, our next step is to seek an equation that relates the volume of the sphere to the radius of the sphere. And obviously the equation that we're looking for is volume for a sphere equals 4/3 pi times r cubed. Now, with this, if we take the derivative of both sides of the equation, over here we'll have dV dt, over here we'll have a dr dt that comes out, so then we'll have an equation that relates dV dt to dr dt. So let's do that. Here we have dV dt equals, this is r to the third power, so we'll take that 3 down, which will cancel this 3. So we have 4 pi r squared dr dt. And you see, this is why you want to find an equation that relates all the variables, because then we can take the derivatives of that. Now I have dr dt is expressed in terms of dV dt, and we know what this is. This is 100. So now the problem is just trivial. We know that 4 pi r squared dr dt has to equal 100. So divide both sides of the equation. This is just this written down here this way. and divide both sides of the equation by 4 pi, and we will have this pi r squared dr dt equals 25 divided by pi, and we have to solve for dr dt when r equals 3. So obviously this would be 9, divide both sides of the equation by 9, and we have dr dt. 25 divided by 9 pi, and that is in feet, not per second though, but per minute. And that's the answer. That's the rate of increase of the radius of the sphere at that moment when the radius is 3 feet in length. So you see, it's not a difficult problem at all to work. We go back to here. We were given what the rate of change of this variable is. We have to solve for the rate of change of this variable. So we find an equation that links the two variables together, the radius and the volume. Then take the derivative of both sides of that equation. So now we can solve for this, or more properly solve for r squared dr dt. And that's it. The problem is over. And for the more complicated ones that we look at, it's going to be the same kind of deal. You're going to be given the rates of change of some variables, and there'll be at least one variable that you have to solve for. And the next step is we have to find an equation that relates all the variables together. Also, for some of the more complicated problems, it's useful to draw a diagram as well. So we'll do that in the future videos. Come back and join us for those, and we'll try and solve some more problems.